Okay, what we're going to look at today, when we start chemistry, what we have to start with is just a little review of physical science. So the video today, what we're going to look at is matter, so the types of matter. We're looking at pure substances versus mixtures. We're going to discuss a little bit about that and start to talk about some changes in matter as the chapter goes on. So to start out with, the first thing in this chapter, it discusses the difference between an extensive and an intensive property. So if you look at the definition of extensive, it's a property that depends on, it's the amount of matter in a sample. The examples that I've given you are mass and volume. So if you kind of think back, and I'm going to have to write a little bit small, if you think back to what mass was when you learned in physical science, it's how much matter is in something. So how much matter. If you take a look at volume, it's the space that your mass will occupy. So both of those deal with an amount. So that's what an extensive property is. Intensive property is a property that depends on the type of matter. So my example that I gave you is hardness. And the only thing to kind of compare here would be a bowling ball versus, say, a tennis ball. So you know from your own experiences that those two are made of different types of material. One is hard, one is soft. So that's what an intensive property is. What we're going to take a look at next, you did learn this in physical science. We talked last year about what a pure substance is. A pure substance is matter that has a uniform and definite composition. The two types of pure substances that you learned about were elements and compounds. So if you think about this, there's a periodic table of elements. So any of those on the periodic table, which is in my classroom or in your book, you can take a look at, but any of those elements like nitrogen, oxygen, chlorine, those are just some examples. Those are elements. When you talk about a compound, those elements have chemically combined. So an example of that would be like NaCl, sodium chloride, or water, H2O. There's two or more elements involved there. So that's what a pure substance is. Looking at a physical property, and I'm just kind of highlighting the chapter here, a physical property is a property that can be observed or measured. So the examples that I gave you were the state of matter of something, meaning whether it's a solid, a liquid, or a gas. Something's melting point or boiling point, its color, or its luster. And luster, if you don't remember, is if something is shiny. So a physical property of a metal is it has luster, it's shiny. Alright, go ahead and move it. If you define the states of matter, and you guys did a project in physical science over this, but the definition of these is listed here, and I've only listed 3. You did do 4 states of matter last year. In chemistry, we won't really talk about plasma much, because plasma is something found in stars and in other atmospheres, so we don't deal with it a lot. You're going to be dealing more with what we see here on Earth for this year. So a solid has a definite shape and a volume. That would be something like a desk. You can't change its shape, you can't change its volume unless you're really, really strong. It's going to stay the shape that it is. But when I look at a liquid, like if I'm looking at water, and hopefully you get used to seeing H2O a lot because that's how I'm going to write water all year. H2O, obviously if I pour it into a beaker versus a graduated cylinder, it's going to change shape. That's what I mean by indefinite shape. It can change its shape, but it has a definite volume, meaning I can pour it from one container to the other, but if I have 50 milliliters, it's still going to be 50 milliliters. Gases, on the other hand, they can change their shape and their volume. So you can compress gases. So when you go to the store and you see those propane tanks, those have been compressed to fit down in the old tank. The other states of matter cannot do that. As a little review, you learned about the kinetic theory last year. If you're looking at the particles, thinking of the particles between a solid, a liquid, and a gas, where do you think is the highest energy? In what state of matter? So if you answered gas, you're correct, because those particles are moving the fastest. You've got to think of it that way. The higher the energy, the faster they're moving. So those gas particles, they have enough space to move around, and that's why they have the highest kinetic energy. We'll get into that more later. I just wanted to kind of review. A physical change. We're going to talk about physical and chemical changes, but just today we're going to be covering what a physical change is. A physical change, the properties don't change, or may change, but the composition does not, meaning it doesn't change what it is. Some examples of a physical change would be whether something is boiling, freezing, melting, condensing, breaking, splitting, grinding, cutting, and crushing. These physical changes can be reversible or irreversible, and I'm going to give you an example. Reversible, if I melt butter. Okay, butter starts out as a solid, but when I put it in a pan and heat it up, it melts and it turns into a liquid. But if I take it off the heat, it's going to go right back to its original form, and it's going to be a solid again. But it still is just a physical change because that is still butter. In either way, it's still butter, whether it's a solid or a liquid. Irreversible would be if I am cutting paper. Obviously, it's still paper when I cut it. It doesn't change what it is. It still has those same properties, but I can't make it go back. I can tape it together, yes, but it's still not the original piece of paper. But I'm not altering it and changing its chemical identity, so it still is just a physical change. The next section of this chapter kind of talks about mixtures and what a mixture is. A mixture is a physical blend of two or more components. I've given you a few examples here. Chicken noodle soup, air, and what you need to understand is that mixtures can be separated. You can separate mixtures, and we're going to talk about that in a minute. And that's why it's unlike elements and compounds, because they can't be separated by just physical means, and I'm going to talk about that in a minute. But there are two main types of mixtures. You have heterogeneous, where the composition is not uniform, meaning you can see the different parts that make it up. So if you think about a salad, it's got lettuce, cheese, tomatoes, whatever else in it. Same thing with chicken soup. A good example that I like to use for this is Rocky Road ice cream, because you can see those different parts to that ice cream. So you know that it's made up of more than one thing. So there's chocolate chips, there's ice cream, there's marshmallow, different parts in there. On the other hand, if you look at what a homogeneous mixture is, it's also called a solution. It's meaning two things are mixed together again. The composition is uniform. You can't tell that something is a mixture. And a good example of this is vinegar. Vinegar, if you've seen it, if you purchased it from Walmart, it's just a clear liquid. But really what it's made of is acetic acid and water. So, but both of those are clear liquids, so you can't really tell that it is a mixture, but it is. Another good example would be if you have salt water. If I put a little salt in some water, it's going to mix. It's going to mix in there and it's going to dissolve. That's what a solution is. But that still is a homogeneous mixture because it's made up of two different things. Now, what you have to keep in mind here is salt is a pure substance. Water is a pure substance. But when I'm putting them together, they become a mixture. So that's where some kids get a little bit confused trying to keep up with that. So just make sure you try to keep the difference between what a pure substance and what a mixture is. Now, I did say that mixtures could be separated, and there's a few different ways that they can be separated. You may be doing some of this year, some of it you may not. I'm just going to kind of introduce it. Okay, the first way to separate a mixture is by using filtration. That would be just being able to separate a solid from a liquid. So in this contraption that I have here, what you have up here, this is called a Buchner funnel. That's this piece right here. You put a piece of filter paper in there, and then you pour the liquid through there. The liquid ends up down here at the bottom, and the solid collects here on top of that filter paper. So a good example of how you would use this is if you've ever made this, and I hope that you have, if you've ever made mac and cheese. When you cook those noodles, you've got to separate the water back out when the noodles are cooked. So that's just a way of filtering something. Another way to separate two things is by separating them by their boiling points. Now, if things have different boiling points, you can use a process called distillation to separate them. I'm not going to explain that contraption there because you probably won't do this in Chemistry 1, but it is important to understand that things can be separated by their boiling points. And I'm going to go back to an example that I used on the previous slide. If you've got salt water, salt has a higher boiling point than water. It has a lower one. So I'm able to separate this out by setting up this contraption to boil that liquid off and get the salt back. Same thing can happen at your house. If you put water on the stove, you put some salt in there, and you let the water boil off, you're still going to see some stuff at the bottom. Now, it's not going to be exactly the same as when you started. It's not going to look like those little salt crystals, but it still will collect at the bottom of the pan after the water is gone. A last way to separate a mixture is to use what's called a centrifuge. Now this, I've got two pictures here. The little vials go in there, and then the lid is closed, and you can see the vials on the picture on the left. But what happens is it spins, and it spins so fast that it separates things out by their densities. So an example of this would be blood. Your blood is a mixture. It has different things in it. It has red blood cells, white blood cells, platelets. So when you put it in this machine and spin it, they may be able to get something out. So maybe they want to get platelets. They can get that out if they want to by using something called a centrifuge. So those are some different things. So to recap here, we looked at what a pure substance was, what a mixture was, what a physical change was, how to separate a mixture. So that's kind of what this video was about. So go ahead and answer the questions that go along with this, and that's your assignment.